Somewhere in the savannas of sub-Saharan Africa, a column of ants is moving across the ground with the kind of discipline that makes you stop and look twice. These are Matabele ants, one of the largest ant species on Earth, named after the Matabele warriors of southern Africa because of how they fight. And right now, they are marching toward a termite mound they intend to raid. The termites will fight back. They always do. Their soldiers have powerful mandibles, and they use them, biting into the legs and abdomens of the attacking ants, trying to pull them down and hold them. By the end of any raid, a portion of the Matabele column will be injured. Some will be missing legs, some will have mandibles still locked into their bodies. And here is where something completely unexpected happens. The healthy ants don't leave their injured behind. They don't step over them. They don't abandon the column and move on. They stop, they locate the injured individual, and they pick them up carefully, deliberately, and carry them back to the nest every time. This is not occasional behavior. This is standard procedure. Not dragging, carrying. There is a difference in the way they handle injured nestmates versus dead ones. The body position, the grip, the direction of movement. They know what they're picking up. They're not confused, not accidental. And they take them somewhere very specific, not just back into the nest, but into a particular chamber set aside for this purpose. Underground, in a specific chamber of the nest, other ants are waiting. The injured ant is placed there, and the nestmates gather. And what happens next is the part that stopped researchers cold when they first documented it in 2017. The ants lick the wounds. Not briefly, not incidentally, methodically, repeatedly, moving along the wound site with focused precision for up to an hour at a time per individual. It is, by any honest description, medical care. Eric Frank at the University of Würzburg led the research team that documented this. When they prevented injured ants from receiving treatment and compared them to those who received licking, the difference was stark. Without treatment, about 70% of injured ants died, most within 24 hours, killed not by the original wound, but by fungal and bacterial infection. With treatment, around 90% survived and returned to normal function. The licking wasn't comfort, and it wasn't social bonding. It was the difference between life and death, measurable, repeatable, and precise. The treatment works because ant saliva is not ordinary fluid. It contains antimicrobial compounds, secretions from the metapleural gland that function as both antifungal and antibacterial agents. The wounds the ants sustain in termite raids are almost always contaminated with soil and biological material, which in humid savanna conditions creates a fast-acting infection risk. When the medic ant licks a wound, it is applying a chemical antiseptic directly to that site, repeatedly, until the contamination is cleared. This is not comfort. This is not social grooming repurposed. This is pharmaceutical intervention, chemically specific to the threat. But the most extraordinary part of this system isn't the treatment itself. It's the decision that comes before the treatment, the moment of assessment that determines who gets carried in and who gets left on the field. Because the ants don't treat everyone. They assess each wounded individual, and some they carry in, treat, and return to the colony as functioning soldiers. Others they leave on the field. The determining factor is the severity of the injury, but not in the way you might expect. It's not about pain or suffering, or even how many legs are missing. It's about one specific variable. Can this ant still move its own legs? Ants with minor injuries who can still partially locomote emit chemical signals that trigger rescue behavior in nearby nestmates. Ants with major injuries who have lost the ability to move themselves emit different signals or none at all, and those ants are left behind. This is triage, not random instinct misfiring, actual triage. a system for allocating limited time, effort, and medical resources based entirely on survivability and return on investment. The colony cannot afford to spend an hour treating every injured ant. There are raids to run, territory to defend, resources to gather. So the system evolved to make a fast, accurate assessment. Is this injury recoverable? If yes, rescue and treat. If no, leave. It is cold, it is precise, and when you look at the survival data, it is almost perfectly calibrated. Frank's team also discovered something that makes the wounded ant an active participant in its own rescue. When an injured ant is picked up by a nestmate, it cooperates, pulling its limbs in, making itself easier to carry. When an ant is too severely injured to be worth rescuing, it does the opposite. It struggles, it flails, it makes itself hard to move. The signal isn't just chemical. The injured ant's own behavior tells the rescuer whether to continue or let go. Which means what looks like rescue is actually a two-way negotiation. The colony offers help. The injured individual signals whether help is viable. Together, the rescuer reading the signal, the wounded ant providing it, they make a decision that neither could arrive at alone, and the system arrives at the right answer almost every time, with no central coordinator, no supervisor, no plan. When the treatment works, the recovered ant returns to active duty within hours, back in the column, back on the raid, fully functional. The colony spent an hour and got a soldier back. The investment paid off exactly as calculated. Now, the question that should be sitting with you: if ants can run a triage system, why do we assume this kind of organized, outcome-oriented medical behavior requires anything like a large brain? The Matabele ant brain contains roughly 100,000 neurons. The human brain contains 86 billion. The ratio is almost incomprehensible. And yet the ant arrived at a working, effective field medicine protocol millions of years before humans did, before we had language, before we had fire, before we had anything we would recognize as deliberate thought. The answer is that the ant doesn't need to understand medicine. It doesn't need to understand anything. It needs a system that reliably produces medical outcomes. The chemical signal does the diagnosis. The saliva does the treatment. The behavioral response of the injured ant handles the logistics. No individual ant comprehends the whole. The colony comprehends the whole, distributed across thousands of bodies, running in parallel, with no individual holding the full picture. And that distributed system, operating as a single organism, gets it right almost every time, without a brain large enough to understand what it's doing. Think about what you actually do when you get a cut. You clean it, you cover it, you watch for infection, you keep it still while it heals. You have antibiotics available if it gets worse. The Matabele ant does every single one of those things in a different chemical language, with a different body, on a different timescale. But the logic is identical. What we call medicine, they call behavior. The outcome is the same. The next time you see an ant, on the pavement, in the kitchen, crossing your path, try to actually stop for a moment instead of walking past. That animal, in that small body, with that small brain, is running behavioral systems we are only beginning to properly document. Systems that were already ancient, already refined, already effective when the first humans appeared on Earth.
We didn't invent care. We didn't invent medicine. We inherited a version of something that was already working for tens of millions of years before we arrived.
That ant on the ground is carrying inside it a medical system older than our species, older than our genus, older than almost anything we would recognize as civilization. It cannot know that. It has no concept of its own history, no awareness of what it represents. It just does what it does: rescue, treat, triage, recover, as it has always done. And it does it almost perfectly, every single time. If this changed how you see the smallest things around you, subscribe. We keep pulling apart the hidden systems behind the wild. The wild mind is everywhere around us. Keep looking. I'll see you next time.